And thanks so much for joining our first DataBytes webinar of 2026. Today's guest speaker is Dr. Yuyang Xie, presenting Breaking the Georeferencing Bottleneck, How AI is Transforming Natural History Collections. Dr. Xie holds a PhD in physical geography from Peking University and is a postdoctoral researcher in the Department of Biology at UNC Chapel Hill. His research interests include landscape ecology and biogeography. Xie's research set out to answer a central question. Can AI automate one of the most time-consuming steps in digitizing natural history collections? And his team found that yes, it can. LLMs not only performed georeferencing with an error margin of less than 10 kilometers, outperforming traditional methods, but also completed the task at a fraction of the time and cost. We're looking forward to learning more about this work in just a moment. I want to remind you to add your questions to the Zoom Q&A feature, and we'll do our best to address those before the end of the webinar today. Finally, this event is being recorded, and we'll add it to the National Consortium for Data Science YouTube channel later this week. Without further delay, it is my pleasure to introduce Dr. Xie.
Thank you. Okay, so I share my screen.
Yep,
Okay, let me see. Okay, hi everyone. Can you see my screen now? See my
looks great.
slide?
Yes.
Okay, good. Thank you. Let me. Okay, let's begin.
Yes,
Yeah.
please.
Okay. Okay. Good morning, everyone. It's a great pleasure that I have been invited to give a little talk about what our lab recently do and some of the results. Yes, as the introductions, we are ecology research and always deal with many biodiversity data. So during our study about that, we found some bottlenecks when we deal with specimens or the natural history collections data set. Uh, we know the AI technology, especially large language models, developed very quickly in these years. So we would like to know how can we use large language model to deal with bottlenecks of when we use natural historical collections. Yeah. Okay. This is all of the this is all of the context that I would introduce to you today. First of all, we would like to know what is a natural collections. If you are not a ecologist, I would like to share with you. For natural historical collections, in other words, is a specimens. This means the specimens that stored in herbariums or the museum around the world. Mm-hmm. Sorry. Can you see me? Can you see my screen now?
Looks great. Thank you.
Okay, good. Yeah, I just found something wrong. Okay, that's good. So, natural historical collections means the specimens stored in herbariums or the museum. And we found that up to now, there are about 2 or 3 billions of the specimens that are stored in over 1,000 natural history museums around the world. So it's really a big data, really a big data database. And they are very important. And in my opinion, they are snapshot of life across time and space and places. They are providing specimens data can dating back over hundreds or even thousands of years. And in some ecology and evolution studies, they are very crucial for studying how species or ecosystem change over the time. So it's really important data for us. And we can see this figure. This figure shows us a life cycle of a natural history collections of the specimens. First, the specimens would be collected in the field, in a mountain, in forest, or even in a river, or even in oceans. And then they would be brought in the lab, and they would be transferred into digital formats using many different ways. And after that, they will be uploaded to the online platform such as GB or another biodiversity database, so that people around the world, whenever you are young or old, can check and download or use them for many different aims, such as use them for educations or even use them for research or any else. And among all of these processes, we think the key to with spare distributions of these specimens is no doubt the digitalization. Yes, transfer them from specimens to digital formats and then storing them in database. Yes, it's an important process. And this process, which is specimens digitalizations, obviously involves converting physical specimens into digital formats, as I just mentioned. And typically, they would through many ways, such as photographies or scanning the plants or the animals itself to upload them as image formats. But we need to know the digitalization of specimens include not only image or photo data, but also textual information, such as a label and metadata. And at last, we would like to know from the information what we can know from them. Maybe how plants or animal look like, and what's the name of them, and where or when people get it or collect it as specimens. Now we can see the digitalized specimens is increasing rapidly. We take Harvard University Herbarium as an example. We can see since 1918. Although the total numbers of the physical specimens has remained constant in recent years, but in the same time, we found that that in recent years, the increasing numbers of the digital specimens has increased rapidly. And also in recent years, there are many increasing numbers of citizen science or biodiversity database that have integrated more and more digital specimens information that all of the people from different fields, from such as researchers or uh, even young or old people can download them whenever you want from this kind of different database. However, due to the age and the limitation technology of the specimen collections, many specimens always lack coordinates, or in other words, the latitude or the longitude of the location where the specimens has been collected. So this issues has become a major bottleneck in digitalizations because yes, for some very old specimens, we always will face difficulties to find where the specific locations of the plants or the animals has been sent. Yes. Uh, As we know, standard specimens usually have locality descriptions written by the collectors at the time of the collected specimens. However, as I just mentioned, due to some technology limitations, not all of the collectors have GPS de devices, especially several decades years ago. So many specimens don't have recorded coordinates. And I would like to introduce that the georeferencing task is a process to do that, determine the true coordinate of a collection based on the locality descriptions. We can see the photo of a example of the specimens. This kind of information is a locality description. It describes the feature of the habitat where the specimens has been collected. But some old specimens like this didn't have a latitude or longitude information. So people need to, based on this kind of information and use many different map or online applications to find the true locations of them. However, according to GBIF, the largest global biodiversity data platform, we can see that as specimens increasing in recent years, yes, increasing in recent years, the new specimens almost got coordinates information or the geographic information. However, many old specimens with stable numbers still cannot have a coordinate records yet. Therefore, up to now, we can see more than half of the digitalized specimens still lack coordinate data. But we need to know current coordinates are very crucial for many research fields like ecology or evolution, which really more on spatial data. So if you are an ecologist or a biologist, maybe you use many study analyze methods such as species distribution models or ecological niche models. So during this period, you can see it's very important for you to know the specific location or specific coordinate of a species of plant or animal it can where it occur or where it has been seen. So the true locations or the specific coordinate is very important. And another thing we need to know is that georeferencing isn't a task just about using a map application such as Google Map to pinpoint locations. For examples, when we give Google Earth, Google Earth an exact place name, it can quickly find the spot. For example, I tell them my location, the location of my office. Yes, they can pinpoint it in the map very quickly. However, we need to know that specimen's locality information isn't always a very clear place names like that. Yes, it describes habitat features, including various relative location details, like many unnamed tree, forests, or even a valley. This makes it much harder for map applications to find that. As can be seen, human or memory georeferencing is really a labor-intensive and a costly task. And as a researchers, we really need a way that can help us to automatically do spatial reasonings and find the true locations for us. Okay. Thus, we are thinking about how to use AI technology to help us to do that. First of all, we would like to introduce a conception or approach which named GeoAI. GeoAI is a conceptual approach that always combines geographic information science and AI technologies. They will use the efficiency of GIS, or in other words, geographic information science, to handle large-scale geospatial data, and using AI to process and manage it across different sources and scales. And there has been a lot of tools out there now use many AI methods such as different deep learning models to automatically pick out place name from tags such as some social media, and then they can give you the exact coordinates very quickly. And one of the most commonly used and professional tools for georeferencing the specimens is geolocate. It was first released in 2003, and up to now, it is still a very commonly used applications or software by museums or herbaria. And the geolocates, and yes, we want to know how it works. First, geolocate would read the place name described in the locality descriptions, and then finding out the place name in it, or the keyword of the distance or directions in the text. Then it can search big data sets such as place names, river mills, legal land descriptions, and highway water body crossings to match the locations on the maps, and then show it for you for a quick check or adjustment. However, many studies find yes, geolocate is very useful and very fast responding, but the occurrences of the software out of Americans always lack uh, lack justified. Uh, okay. We know in these years, large language model demonstrate great potentials in text meaning capabilities. We consider large language model have so strong reasoning abilities, so we want to know how can large language model help us to do these tasks about georeferencing. And in recent months, our lab has published papers about how to using large language model to address the georeferencing task of the specimens. And this paper has been published. It's a commentaries papers that published in Nature Plants. And in this experiment, we have compared how accurate and efficiency large language models are compared to different commonly used georeferencing methods. The experiments used over 5,000 plant specimens records from around the world from the largest biodiversity database, the GBIF platform. And all of the record we collected have the locality description like this. This is some examples. And all of them has true coordinates, latitude and longitude for reference. And the method we compared include three. The first, of course, is large language models. Yes, we take different versions of ChatGPT and DeepSeek as an examples, and using this kind of prompts to chat with them. And each prompt including, oh, I'll tell the large language model you are ecologist or what you are doing. Yes, you are going to georeference things locations, and then I will give them some example about what the input data or the locality information look like, and then I would give them a example of what we would like it to output. yes, the true coordinate. And the second way we compare is use the geolocate software we just mentioned about. And finally, we also use human methods as comparisons. We have 10 people to georeferencing only use their eyes and the Google Map applications. First, the people would search the object name mentioned in the locality descriptions for finding a general extent, then use the measure distance tools in the website to find the specific locations according to the direction and the distance that mentioned in the text. Okay, let's see some results. There are example of georeferencing results compared with human and large language models. We can see in this place is urbanization areas. Maybe we can see, yes, the red point is geographic result from humans, and the blue is for DeepSeek, and the yellow is for ChatGPT. Okay, maybe in these situations, we can see people or human can perform better. But when we move our eyes to some remote area or some rural area, uh, the scene has changed. We can see we can see the human's eye always finds the wrong locations compared to the true locations. And under these situations, we when we think about the mean value of the error distance, the human performance and the large language model performance is not significant different. Okay, overall, we found that in this battle between human and the machines, the overall accuracies of human georeferencing uh, was not significant different from the advanced large language model at that time. Mm. And on the other hand, we can also find the geolocate, the professional tools, perform not better than the new version of large language model, but still perform better than the older versions. Uh, we need to notice that we performed the research half a year ago, so we know that now the most advanced version of ChatGPT is 5.2, but at that time, the 4.0 is the newest, yes. And we also know that we often pay for ChatGPT, but we also need to know that professional human georeferencing also requires payments. Let's see these figures. The x-axis are the georeferencing errors, which means the coordinates of the large language model or human georeferencing results compared with the reference true locations that's recorded in the GBIF database. So this means more lower, more current. And the x-axis are the time and money cost. So more left, more efficiency. And we can see the overall negative relationship between the currencies and the cost. And we can also see the old version large language models and the geolocate geolocate methods. Yes, they are free and the quickest. But at the same time, the last accurate. But we can also see human performance. Human were the slowest, but the most accurate. However, uh, most expensive, yes. And we can also see new version of large language model were in between. Both performed better but perform better than expected because they are located under the fitted curves. This means they are more cost and effective balanced compare among different kind of commonly used methods. And the next questions we want to know is distributions of the georeferencing area of the large language models. We take the result from ChatGPT 4.0 as an example. We can generally see that the area is smaller in some developed areas such as the West Coast and the eastern of Americas and the southeast of the Australians and the central and the West Europe. But at the same time, we can see the larger areas are concentrated in many rural or mountain regions, such as the medium Americas, where the Rocky Mountain located here. And we further use human footprint index to measure the human activities. We indeed found a positive relationship or a negative relationship between the area distance and the human footprints. Or in other words, a positive relationship between human activities and the large language model occurrences. However, we found also the large language models can be influenced, but it is more stable than other methods such as professional software because of the the professional software is always more influenced by the human activities, but the large language models the influence by human activities is much less. So it maybe is more stable at last. And then we further explore the factor that may cause the errors. And we can see this figure. This figure shows the correlations between the factors and the georeferencing errors from different kind of methods. And only the significant relationship are labeled here. We can see the blue colors means the factors is good for decrease the errors, while the red means the factors is increasing the errors. First, we found that we didn't find a very strong link between how readable the text was and the georeferencing occurrences. And we need to notice that the readabilities were indicated by many metrics. So anyway, we can see that how readable a text is not a key influence factor for the accuracy of large language model georeferencing. But meanwhile, we can also find some keywords about the name of rules or the name of a road or building or other objects, as well as direction such as the west, east, to the north. Yes, this kind of keyword can help to increase the occurrences. But some keywords like the distance didn't have that. This suggests that my large language model spatial reasoning still has a long ways to go or a long way to develop. And still, more complex spatial informations maybe still can make georeferencing by large language models be harder. And another study also proves that. And in this studies, they use different ways of describing locations to talk with chat with large language models such as ChatGPT. We can look at this confusion matrix. We can find that many complex location relationships, such as northwest, southwest, so they are the complex location descriptions always cause large language model make more mistake in reasoning. So this also supports that large language models still struggle with some complex spatial reasoning. There are a long way to go to improve it. And then, according to other studies, there are even some tools can even spot landmark in images or photos and figure out the exact coordinates just from pictures, photos. We can look at this. This tool can help us to accurate and locate places in the world just through the photos. But we can see all of the photos have a very famous or very exact buildings in the pictures. But as for the specimens data, we just mentioned that most of the specimens were collected in the field, such as remote area or mountains or even in valleys. So the habitat was like this. So under these situations, how or can large language models help us to pick out these places? I think we need to do more tasks. Okay. Yes, let's say some take-home message. First of all, in our experiments, we found that large language models can offer efficient, cost-effective georeferencing methods with very near humans accuracies. And we can also see large language models still have some limitations in complex or remote locations in terms inference, but still outperform some existing software based on the database instead of the large language models. And based on this, we think that the best way we use large language models to help us georeference specimen data is to combine large language model with humans. For example, we can first use a large language model to give us a much smaller extent of where the specimens used to be. And after that, based on this small extent, people can take less time to find the specific locations in the map. And maybe in the future, we are thinking about how to improve the performance of the large language model georeferencing. We think maybe it's a good way to integrate many historical map and context with to the large language model. This may can help us to enhance the large language model performance. In other words, maybe we can train the models with more old maps and old place name. So in this ways, maybe the model can learn more about the spatial distributions of the uh, places in the histories because we need to know that most of the specimens without coordinate information is always some old specimens that has been collected several decades years ago without GPS devices. Okay. Yes. And we also need to say that we are very interested in this field, but we are not a professional computer scientists. So we are very happy to connect with you and if to do some work combined with ecologists and computer science and and also AI technology. So that's all about what I would like to share with you, and I would like to thanks to my lab and collaborators, and also thank you for your attention. Thank you very much.
Yu Young, you did a fantastic job, and that is evidenced by the chatter that we've seen in the Zoom chat, as well as the great questions that we've received in the Zoom Q&A.
Okay.
So we are going to take a few minutes now to review some of these questions that have come in through Q&A. Does that sound good?
Yes, I'm reading the Q&A chat now. So okay, let's so first of all, a question. Okay, let's see the first questions. Yeah, thank you very much. Thank you. Thanks to Allison's. Uh, we are digitalizing the international herbarium specimens, which sometimes do not even list the countries the plants was collecting, or list an old name of countries, province. Curious to learn how your models handle this problem. Yes, that's a really a good question, and we also face these questions. And as I just mentioned in my take-home message, and actually we didn't really deal with this question, but we are finding the way to deal with that. Yes, I think maybe the best way we would like to think about maybe train the large language model with many uh, history many historical maps or even some map that for many different kind of countries in different scale. Maybe yes, maybe in the future, if the large language models can read more and more historical maps or map from different country, different province, or even different counties in different time scale. I think time scale or spatial scale. I think this may be considered uh, consider the excellent learning abilities of the large language model. Maybe I think maybe we can uh, help to improve the ability of the spatial reasoning of the large language models in different time scale or spatial scale.
Great. And I think
Thank you.
somewhat related to that, I'm going to jump down a little bit to another question that's written here from Carol Ann McCormick. Do the AI tools match the collection date to the date of the map used? A map from 1910 will have place names and road locations that are significantly different from a map produced in 2025.
Mm, yes, there's also the question we just mentioned
Yeah.
about. Yes, we are. Yes, what my lab are doing now is to collect or deal with the different formats of the map, or some even only in the papers, not digitalize the map. And yes, mm, we are now doing to collecting this kind of map. And also, yes, also we are connecting some computer scientists to think about how to integrate this kind of different kind of maps to the large language models. Yes, I think yes, I think it's a very good directions to help to improve the models for for our yes ecology studies.
Mm.
Yes, thank you.
And this is a good question. How accurate are LLMs at transcribing handwritten herbarium labels?
Uh, oh, you mean the, yes, let me see this kind of.
And we do have a couple of other questions about specific slides as well, so I'm glad you kept this open.
Mhm. Yeah. Okay. Yes. Yes. Actually, some of the old specimens, especially some specimens that's collected before the develop of GPS, most of the specimens have the label like this. Yes,
Mm,
write by hand. As I think, for this question, maybe the most important things is to use a model to transfer the photos to the digital formats, or can different kind of the different language can be indicated by the large language models. Yes, I don't know how good it can uh, transfer the written words into the digital world. Because in my experiments, it just use the digitalized specimens as a reference. But in our during our study, we found that the language models, when we use a large language model to deal with different language of the locality formations, is different. Maybe up to now, or up to what we performed the experiments half a year ago, we found that it can do better in the English informations,
mm,
but always make more mistake. But for most time they did they did better. But sometimes they would make some mistake when dealt with the description in other language.
mm.
Other than English. So maybe yes, it's a good question to explore.
Hmm. Hmm.
Yeah.
So I am going to hop down to a question from, let's see. Oh, this is a great question, asking about helpful tools, either plugins or other scripts that help with georeferencing textual locations. Particularly those tools that might be low cost or free.
Yeah. Actually, yes, our lab are doing try to develop a sort of software now. But as for the cost, I think maybe now when we use the API from ChatGPT, We also need to pay monthly, or
Mm,
based on the yes how long we used. So uh I don't know if there would be a free software in the future, but now yes we have what now we are going to do, or we are doing, is just to develop more friendly software that can all of the people can use, just like using Google Map,
hmm.
instead of using so many codes to run the models. Yes,
Mm,
we are doing that, and we also would like to ask some collaborators that with different background of computer science or AI technologies. Yes,
mm.
thank you.
Good. Yeah, I know we have a few folks from with computer science backgrounds on this call today,
Yeah.
so hopefully they'll be reaching out with some opportunities to collaborate, and we can make that happen for sure. So we have a specific question for slide 28, and I hope that that number is correct. But from the anonymous participant, how are the factors causing errors identified or defined?
Mhm. Mm, yes, that's a questions. Yes, yes, we found some keywords is out of our what 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 we used to think is to be such as maybe we can see these factors distance, which means numbers of such as a in the northwest of B from about 2 mile or 10 kilometers, such as this. And we found that large language model can make some mistake when deal with this kind of numbers. So in these figures, we point out that maybe some distance would do some didn't help the increasing of the currencies. And about the why it like that, maybe when we use many of uh, the number. First of all, we need to know that in the level in the level of the locality description that's written by the collectors, some of the distance, like 10 mile or 2 mile is not an exact distance because people don't always use GPS devices or even measure tools. So maybe the number that has been written down in the labels is not a real distance. And when the description uh, was full by this kind of not exact numbers, maybe in some distance uh, they would mislead the large language models. I think this may be the one of the one of the factors. And about some technological uh, reasons. Yes, uh,
Yeah.
such as can large language models really understand the distance in different units, like mile or kilometers? I think this is not a problem. So yes, about why actually, to be honest, why the distance can mislead can sometimes mislead the large language models. We are still yes still exploring that.
Mm. So Scott Ward raises another interesting challenge in the Q&A uh, questions here. Unfortunately, for many rare species of plant, their initial habitat has disappeared. I'm curious if you ran into this at all, where the georeferencing was made more complicated because of land conversion.
Yes, that's a good question. Yes, we know as the land use changes over these years. Some old habitat has been destroyed. Uh, yes, this is the next step we would like to do, combine with some old map we just mentioned above. Actually, in the papers we do the performance and publish recently, we only deal with the records or the specimens that have been collected uh, after 2000 years. Because in this test or in these experiments, we need to get exact locations or exact coordinate for reference. So we didn't have we do not have try very old specimens. But I think yes, it's as I just mentioned, it's really important issues or very important questions is to ask or find a way to train the large language models uh, to get knowledge about more and more old information or historical information, such as how land use change and how the habitat changed over decades or even hundreds of years. And I think after we found the way to train them and get them to have this kind of knowledge, maybe we can it would be helpful for us to do some researchers in different time scale and spatial scale.
Hmm. Thank you.
Thank
And
you.
here is another question from um, a guest asking, how important is the accuracy of coordinates in relation to ecological research? I understand that more accurate is better, but there's probably a point where you reach diminishing returns.
Yeah. Uh, yes, I think as for ecological researchers or students, many methods I just mentioned we usually use uh, is a special a species such as species distribution models or another name ecological niche models always combine with environmental raster data and the occurrences of the specimen's data together to predict how the specimens distribute now and in the futures. So I think the good balance uh, is to make the occurrences or the uncertainties of the georeferences coordinates with the resolutions or the pixel size of the environmental data we use. For example, we found that we can see this result. Uh, yes, because in this result, some goods uh, the human georeferencing and the more advanced version of ChatGPT for all can get the medium or the mean mean of this error distance is about I remember is about no more than 10 kilometers and considers some of the climate data or some environment data always with 1 kilometers or to 10 kilometers or 1 degree resolutions. So I think the best balance to improve the accuracies is to make the error distance under the resolutions of the environmental data you are using. For example, if you are using the water climate data, what climate data is a climate data around the world with about 1 kilometers resolutions. So the best balance, I think, to make the points make the uncertainties of the point of the coordinate of the points can no more than the 1 kilometers. So yes, so overall, I think the best balance is to make the uncertainties of the georeferencing fit your resolutions of your data,
Hmm.
of your environmental raster data. Yeah.
Okay, that's super helpful. And then we're going to have time for just one more question. This is taken from our registration form, and I dropped it in the chat box. But this is kind of zooming out and asking you to look at your crystal ball. But how do you envision the role of AI in this field shaping the future of collections? And that really
Yeah.
Complex question for sure. Um, but just predictions and how things might change maybe in the next 1 to 3 years.
Yeah, I think, it's really hard to say because I'm
Yeah.
not a professor, but I think it would be a real, unless it would be a real short times because maybe, yes, I think in these years, from 2025, we really see the AI technology improve very deeply. Not only just for deal with textual informations, but also for the image and the videos. Yes, as the videos. Yes, I think it's I really can't how large language models or how AI would develop in the following years. Yes, maybe we can take our eyes on it and keep hopeful.
Yes. Okay. Well, lots to explore together. What I'm hearing is a call for collaboration and a call to kind of come together with a variety of fields, including folks from computer science, maybe, and other spaces, and to kind of explore these questions together. So, thank you so much, Yu Young, for your time and for your presentation. All of you, it's been a pleasure learning together, and we encourage you to dig into future NCDS programs. The National Consortium for Data Science is a project of the Renaissance Computing Institute at UNC Chapel Hill. And we have some exciting programs coming up, specifically with our Illuminating AI series, which is a partnership showcasing the work of scientists at RENC and the North Carolina Museum of Natural Sciences. So these events that I'm about to share with you are hybrid and open to the public. So scan that QR code, get registered. We would love to have you join us for Alex Jensen's presentation, How AI Catalyzes New Biodiversity Science. And then our next slide talks a little bit about a Zoom panel we have coming up, How AI Reveals Hidden Stories in Nature. This features Dr. Angel Shu, Dr. Roland Kays, and Dan Morris. Really interesting folks debating some cool questions around and exploring some ways that AI reveals hidden stories in nature. So you don't want to miss that. And we are happy to additionally share information about another spring career panel that we have coming up. Um, Next week, actually, next Thursday. We'd love to have you join us for that. For those of you, for those of you interested in exploring different career paths in data science and beyond, we've got a great lineup for that event. So thanks again to all of you for joining today. We do hope that you'll be able to complete our evaluation so we can learn more about how to make these events better and how to bring more speakers to your attention. And yeah, feel free to reach out to us at any time. My email address is amiller@renci.org, and I'd love to hear from you. But thanks so much for joining us today. Dr. Xie, thank you so much for your time,
Thank you.
and
Thank you very much.
thank you. And I do hope to continue the conversation. All right. Thanks so much, everyone. Take care. Bye-bye.
Okay, thank you.